In 9.4, we're going to be looking at testing the difference between proportions. It is a modified z-test. The formula you see below. The new area, the new value for us, I should say, P bar and Q bar. We haven't seen those before. We've had P hat, we've had Q, but with P bar, what you're doing is basically finding the mean or the average of your proportions. So if you notice, you have x sub 1 over n sub 1. That's your P hat. X sub 2 over n sub 2. That's your P hat sub 2 from your second proportion. So basically you're taking your two successes from your sample proportions and adding them, dividing by the two sample sizes added together. So that's a new idea for us. We haven't seen P bar before, but then P bar and Q bar are related the same way that P hat and Q hat are. So if you want to find, if you know P bar, you can find Q bar by doing 1 minus P bar, or we can also do the relation P bar plus Q bar will equal 1 for you. Okay? So those relationships are still the same. The idea of P bar and Q bar, that's the new idea for us with this z-test. Our samples must be random. Sample data are independent. I know in 9.3 we looked at dependent samples with the mean of those. We are back to our independent samples. They're not going to be related at all, not paired up, not matched up at all for us. For both samples, n times p has to be greater than or equal to 5, and n times q greater than or equal to 5. And again, these are assumptions, so things that we get to assume to be true, since we are not actually the researchers designing the study and collecting the data. We do also have, and I just put all the formulas up front, the example we're going to do, we'll just do a hypothesis test and we'll do the confidence interval. We'll just link both of those together, show how they back each other up. So our confidence interval formula looks like a whole bunch of P hats and Q hats. It's not quite as bad as it looks, but we will go through that. We do not have a P bar in there to worry about. That's just in our Z test value for our hypothesis test. All right, so since you guys had already outlined all that stuff, let's go ahead and let's take a peek at our examples. So just go ahead, take a minute and read through the question. All right, so since we are comparing two different proportions from two different populations, we have our males and our females. We do want to designate, before we get into writing our hypotheses, we do want to designate which is going to be our P1 and which is going to be P2. So let's go ahead, just so we're all on the same page, I'm going to say that P sub 1, we're going to say are the men, or the males, however you want to state that, and P sub 2, I'm going to have be the women. When we state our hypotheses, that's still our step 1. Our null hypothesis is always going to be the one that states there's no difference. So P sub 1 equal to P sub 2. You can also state that. Remember another way to state that? P sub 1 minus P sub 2 equals 0. So again, that null hypothesis is just showing that there's no difference between those two proportions. So however you want to state that, you sure can. The alternative hypothesis, that's when we're looking to show some kind of difference. And in this case, it says the proportion of men being greater than the proportion of women. So our men, this is where our labels come in handy. If I don't know which is which, I have a really hard time writing my alternative hypothesis. So if I know that P sub 1 is men, I want to show that that's greater than the women. That would be our claim. And again, you can also write that, and I've seen some of you choosing to show the difference in your hypotheses when you did it on your quiz or any questions I've taken from you. You can also actually write it showing the difference. Either way is okay. Either way is perfectly fine. If you go to use the calculator, you're going to want that first way. So now let's talk about step 2. I wanted to do one today using the p-value method. Some of you are asking me, I've been assigning p-value stuff on the assignments, and I haven't gone through a p-value method and actual example in class. And the reason why is because p-value, it hasn't changed. So if you're doing a z-test, how you find your p-value isn't any different than last unit. If you're doing a t-test, how you find p-value isn't any different from last unit. But just to kind of refresh you on things, if you need that, we're going to do a p-value today instead of the traditional way. We've been doing a lot of traditional. So with the p-value, our second step is to find our test value. In order to find our test value, I like to list out a few variables first. We need p hat for our p sub 1, and that is our proportion of men in this case from our sample. And it says we're given a percentage of, we're given 78 out of 250 men. This works out to be a nice decimal for us. Remember, you don't want to round. If you're a proportion, if you try to change it to a decimal and it doesn't work out very well for you, it's a non-terminating decimal, or if it ends up being a repeating decimal, you want to go with your fraction. All right, we also need p hat for our second sample, which is our women, and we had 58 out of 200 women, and let's try that out. And we get another nice decimal. The decimals to me are just easier to use if I'm trying to plug and chug in the calculator with the formula. I think the decimals are far easier to use. The other pieces that we need before we can start digging into our formula here, we need p bar. P bar is new for us. It's where we take our number of successes, or our numerators, if you will, from both of the p hats, divided by our sample sizes added together. So if we add those together, we want to do a nice simplified fraction if we can. The numerator starts off as 136 out of 450. It ends up being a repeating decimal, so the best we can do is just simplify our fraction. And to be honest, you wouldn't have to simplify your fraction. It's up to you. You want to just leave the 136 out of 450, you can. It doesn't matter. But since it's a repeating decimal, I can't just go decimal form. I'll throw my stuff off. All right, then we also need q bar. Q bar is just 1 minus whatever p bar was. So those are all the pieces that we need in order to do our test value formula. Those are all the pieces that we need. So let's go ahead, do a z equals. The first part of the formula, we have our p hat sub 1 minus our p hat sub 2. So p hat sub 1 minus p hat sub 2 minus, and we see we have just regular P1 minus P2. Again, those are the population proportions. We don't have those. The information we're given would be from a previous study. If we had the actual population proportions, we wouldn't be doing a hypothesis test to see what they might be. Okay, so we don't have those. We want our hypothesized difference. Our hypothesized difference is 0. So similar to what we saw when we did our testing for the difference between means with the z-test and t-test, when we had mu sub 1 minus mu sub 2, it's what we're hypothesizing that difference to be. And if we're not given a specific difference in our information, the difference will always be 0 for us. if we're not given a specific difference. Now we go into the denominator. We have a radical down there. And we have P bar times Q bar 1 over our n sub 1, which is our first sample size, plus 1 divided by 200, which is our second sample size. So now just take a minute. I know, yes, there is a calculator program shortcut for this, but I know that a lot of you out there, you like to do the formulas by hand, and you like to use that program and the calculator as a double check. Especially come test time, you like to make sure that you do a thorough job on your test, and I don't blame you for it. I'm the same way. So just take a minute, do some plugging and chugging, and double check me. Maybe I entered something in wrong. Double check me, see if you can come up with the same thing I did. And I know for most of you, once we reach this part, once we get past the, here's how we write the hypotheses, here's the new test value formula, I know most of you out there are like, yeah, Miss Gal, I don't need you anymore. I'm ready to rock and roll because all the steps are the same. But I will go through a p-value with you. That is our step 3. And I know for those of you that like to use the calculator, oftentimes you kind of gloss over, and I wasn't super picky in your last test, but you kind of gloss over the step 2 of finding the test value. The test value is how you would have, was what you would have to use to find your p-value. It's what the calculator uses to find your p-value. So step 2 should be find your test value. I was pretty generous in the last test. I didn't mark it wrong if you didn't give me the test value. This next test I will not be as generous. So make sure that you do list out your test value. You need to make sure you can find that yourself as well. Even if you are just getting it from the calculator, I want to see that you can pick that out. All right, so finding the actual p-value. You have a couple options. If you're a table person, totally fine. I know I still have table people, calculator people, doesn't matter. Z-test, so we go to table E. Table E, and we find your test value is a z-value. So I'm going to look here is hang on, I need to scroll down for a minute, guys. There we go. Alright, so I need to find where z is 0.51. So here's 0.51. So again, p-value, p for probability, represents an area. I need the area. Now this is a right-tailed test. So I need the area in the right tail that relates to 0.51. The area in this table, remember, is to the left of our z-value. I need the area to the right. So if you want your p-value, you need to do 1 minus the value that is in the table. Again, and I'm doing this because it's a right-tailed test. The table gives me the area to the left. P for probability. Probability is the area related to our test value. So I don't look up 0.51. I don't try to find it in the body of table E. 0.51 is a z-value. So I use the outside column in that top row. It is a z-value. So I would come up with, if I did the table, my p-value would be 0.3050. So that's using the table. Again, use the outside columns. If you're a calculator person, we need to go second vars, normal CDF. My lower, since I want the area to the right because we're a right-tailed test, my lower value is going to be my 0.51. My upper value, I want it to go to infinity, essentially. So to show that in the calculator, we go second and then the comma gives me the E, and then I put 99. Mu is 0, sigma is 0. We want to paste that in. Now, if you have an older calculator, do the normal CDF, and then you have to enter things into the parentheses like I have up here. But you don't have to enter the 0 and the 1 at the end. You don't need those things. You don't need those things. So if you have an older calculator, you want to do this. This will give me the area to the right of 0.51. You don't need the 0 and 1 at the end. So that's if you're using the test value to find your p-value, table or calculator style. Totally your choice. So if I do the calculator, I end up with the same thing. I end up with the exact same thing. So that would give me my p-value. And so we have p-value equals 0.3050. So step number 4, to reject or not reject, just a little refresher on that. If your p-value is greater than your alpha, remember alpha is the area that would relate to our critical values if we found them. We don't have to for p-value. So remember, alpha is going to be the area in that right tail. If my probability, my p-value, if that area is larger than my alpha, that's when we do not reject.
Excuse me, teachers and students.
All right, so then, now if the area for your p-value is less than or equal to your alpha, that's when we reject. Remember, guys, that's step number 4. And most of you out there were fantastic about this on your last test, so I'm not too concerned about the next test. But remember, step 4 is all about rejecting or not rejecting the null hypothesis. Nothing to do with your claim at this point. So let's check this out. What was our alpha value for this? 0.05. So our p-value was less than, it's 0.05, excuse me. So our p-value is greater than our alpha value. So for our situation, we do not reject. But I just wanted to make sure I refreshed you on both. Then step number 5, we didn't reject the null hypothesis. So that means I can't support the claim that's sitting in the alternative. So there's not enough evidence to support the claim that the proportion of men who never married is greater than the proportion of women. So this would be the only new pieces for us compared to what we've been doing. How we state our hypotheses. So far we've seen a bunch of mu sub 1, mu sub 2, a mu sub d. Now we're back with proportion, so we have that lowercase p. Nothing different from what we saw last unit, and actually the unit before when we did confidence intervals. So really how we're stating our hypotheses, and then our test value formula is new, but it's a z-test. It's still a z-test for us. So how we find our critical values if we needed to. If we needed to find critical values for the traditional method, it's the same that we did for all of our other z-tests. Same thing. So let's take a look. If we find now the 95% confidence interval for the difference, keep in mind the reason why we're doing 95% was because our hypothesis test, our significance level is 0.05. So the matching confidence interval would be 95%. All right, so to find, here we go. We need to find, though, we have our list, we have p hat sub 1, we have p hat sub 2, but the other piece we do need is we need q hat sub 1 and q hat sub 2. We do need those pieces for the confidence interval. We do need those. So 1 minus p hat sub 1 was 0.312. And then 1 minus p hat sub 2 was 0.29. Now I know this confidence interval formula, it's got a bunch of stuff going on. We got lots of p hats and q hats and things like that. So here we go. We start with p hat sub 1 minus q hat sub 1 minus, now here's the catch though, we do have a z sub alpha over 2. We didn't find critical values for a two-tailed test. So take a minute. I know some of you are like, oh, it's just going to give me the calculator version anyway. But take a minute though, guys. Find your z sub alpha over 2. Your confidence interval is 95%. So remember, to find z sub alpha over 2, guys, you have to divide. You have to divide your alpha by 2. And then you have two choices. You can do the inverse norm on your calculator for 0.025. Or you can take a look through the body of table E, find as close as you can to 0.025 and find the z value that matches. Again, this is the same. We didn't do it in this example, the one before it. This is the same thing as finding critical values for a two-tailed z-test. Same thing. So you should come up with 1.96 for your z sub alpha over 2. Then we get into that messy looking radical. P hat sub 1 Q hat sub 1 divided by our first sample size. P hat sub 2 times Q hat sub 2 divided by that sample size, which was 200. Whether you're going to use the calculator shortcut or not, you still have to have the correct symbols in the center of your interval. We're looking for a difference in proportions. So you have a P1 minus P sub 2. We're looking for a difference in proportions. You might be thinking, well, how do I know that those are the symbols? Because I would ask you for a confidence interval for the difference of two proportions. Remember, difference means subtraction. The other side of this, it's the same thing. I'm probably going to run out of space to write it. Same thing, but we add 1.96 and then that whole messy radical. I'm going to see if I can squeeze it. Don't think I'm going to make it. All right, when I did this, I came up with, and you can double check me on this, please, please do. With our proportions, remember, we want to go a minimum of 3 decimal places. Because oftentimes proportions, if you're doing a confidence interval, if you round to just the nearest tenths, if I rounded to the nearest tenths in this situation, I just have negative 0.1 to positive 0.1. Might not give me as diverse of a nice window there. Or we saw it when we did confidence intervals, if you do proportions, you round to the nearest tenth, sometimes you end up with the exact same thing as your minimum and your maximum. So that doesn't help you make a comparison very well. So take a look through, try it out. Like I said, I know a lot of you are just going to jump to the calculator shortcut, which is fine. But I also know I have a lot of you, based on the last test, that still like to do the things by hand. And then some of you then use the calculator to double check. So double check, and then we'll talk about what this means. All right, so why do we find the confidence interval? It backs up our hypothesis test, or they back up each other, I should say. So what we're looking for a hypothesized difference, if it's in the interval or not. Our hypothesized difference, if you go back to our null hypothesis, our hypothesized difference was 0. We hypothesized p sub 1 minus p sub 2 equals 0. That's our hypothesized difference. So I take a look, and I see that the confidence interval contains the hypothesized difference of 0. So we would not reject the null hypothesis. If our confidence interval contains the difference that we're hypothesizing, we're not going to reject it, we're going to keep it. So then we can also say something to the effect of this agrees with hypothesis test results, or something along those lines. So that's what we're looking for. You have to go to your null hypothesis. What is your hypothesized difference? Is it 0? We've had ones that aren't. We've had ones that are something else. How do I know if I'm supposed to use something else? It will actually say it in the information that you're given. We're looking to see if there's a hypothesized difference of 2%. So then I would look for 2% in my interval instead of 0. I do want to take some time and show you, if at this point, guys, if you've already checked out the calculator stuff, you want to dig into your assignment, go ahead. But if you want to do calculator stuff with me, I am going to do that up here, show you where to find the stuff. Again, calculator steps, page 527. If you haven't already kind of gone there already and tried things out, I'm going to go through them up here. Stat and tests. If you want the hypothesis test we did, we need the 2 proportion z-test. This is for the hypothesis test piece. Now, when you enter these in, here's where you have to be careful. I know some of you ran into this issue last unit because the setup was very similar in the calculator where we just had a single proportion. The x1 is your number of successes for that first sample, or how many, actually the actual number of items in your first sample that have the characteristic we're looking for. So your x's are not decimals, they're not percents, they have to be actual integers. They have to be actual whole numbers would be a better choice for that. So we have to enter in, we don't want the decimal that we found, we want the actual 78 out of 250 men. Then for x2, we want the actual 58 out of 200 women. We want to show that P1 is greater than P sub 2. There's all of our values. Now I know you might be thinking, but Miss Golly, the p-value was different than what we found. And it will be, because the calculator will not round its z-value to the nearest hundredth to find the p-value. The calculator will use all those significant digits there to find its p-value. So they will be a little different, and that's okay. That's absolutely fine. It'll also show you what your p-hat1, p-hat2, things like that, what those should be. It will actually show you those different things. It will also show you this little p-hat right here. I don't know why they put a little hat on it. That is actually your p-bar. I don't know why they put a little hat on it. That's actually your p-bar. And then your 2 sample sizes. If you want the confidence interval, we want a 2 proportion z interval. For my calculator, it's option B. And now, I don't know if all of your calculators do this or not, but for me, if I do a 2 proportion z-test, and then I go to do the 2 proportion z-interval, it transfers all my information. I don't know if all of them do it or not. Mine's a very new operating system. I don't know if yours will do it or not. Same thing though, guys. Your x's have to be whole numbers. You cannot put a decimal in there for your x's. They have to be actual whole numbers. They cannot be decimals. Confidence level happens to be 0.95. Calculate. And that's the same thing we got when we did it by hand. That's the same thing. So again, if you want to use the calculator stuff, hey, that's totally fine. I know a lot of you, again, I'm one of those people, it makes me nervous to just throw some stuff in the calculator and I just write that interval on my paper without doing any of the work myself. So I would always do the formula, then I double check with the calculator, but that's your choice. Totally your choice.
So what if you don't?